Hey guys, Miss Whitlock here. I meant to do this after school today, but time kind of got away from me, so I apologize. But I promised all of your kiddos that I would do a video tonight, so maybe they can actually tune in. Remember, you can type in questions. You can click the screen with hearts to say you like it. You can let me know you're here by typing in, who's on. Anyway, we're going to be looking at break apart one factor. We've been working on this since last week. So I'm going to go ahead and get started. I'm going to start with an area model. All right, hang on just a second. Okay, so I'm going to start with an area model, and I'm just going to come up with a multiplication problem. Alright, and so I need to know the space inside, so I'm going to count my rows. I have 1, 2, 3, 4, 5, 6, 7 rows. Now I'm going to count my columns. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 columns. Okay, when students in 4th grade are supposed to know their facts through 12. They don't know through their 15s. So we've been learning how to make a multiplication problem into 2 easier problems. So if I wanted to break this apart, I'm going to come in and I've broken my area model into 2 smaller models. So I kept the 7. We only changed one factor. My problem is, sorry, I should have written that up here, 7 times 15. So I'm trying to solve 7 times 15, the area inside my rectangle. So I'm going to break it apart to 2 smaller numbers, I'm breaking the 15 into 2 smaller numbers. I only break apart one factor. 7 and 15 are factors. So I'm going to keep the 7. I kept 7 rows. And I'm going to break apart the 15. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. So now I'm breaking apart the 15. So I have 10. So to make 15, I should have 1, 2, 3, 4, 5 columns. Okay, so I've broken apart again the 15. 10 plus 5 gives me 15, and I kept the 7. So this smaller area model now represents 7 times 10, which is 70. And this model now represents 7 times 5, which is 35. So this area model lets them have a visual of how we can break it to 2 smaller, easier problems, more friendly problems. And also, if we were to write equations for it, it would look something like this. My original problem was 7 times 15. And that equals 7 times 10 plus 7 times 5. Some of you who are familiar with properties may see that this is going to look and is the distributive property. So I'm proving that I have broken one factor down. I kept my 7. I broke apart the 15. 10 plus 5 gives me my 15 back. So now I know that 7 times 15 equals 70 plus 35. So 7 times 15 equals 70 plus 35 is 105. So in class, we have been using array cards and all kinds of things. We've been manipulating them. They've been putting smaller ones in bigger arrays. We've been practicing lots and lots. We've done lots of visual models. And then we started going to the equation form. I'm going to show you how this works with an even bigger problem. But I'm going to just write the equation and break apart one factor. Again, we can only break apart one factor. So I'm going to say that we have a problem. Let's say a story problem that I'm making cakes and I need 16 dozen eggs. So I need 16 dozen. In each dozen there are 12 eggs. Okay, well I practice in 4th grade my facts through 12, but I don't practice through my 16, so I decide that I'm going to break apart my 16 factor. That means I'm keeping 12, so my equation is going to look like this. 16 times 12 equals, I'm breaking apart the 16. I look right here in my tens place and I have 110, and I know 110 has the value of 10. I also know that multiplying by multiples of 10 is a lot easier, so I've got my 1 is worth 10 times 12. I'm keeping the 12. Now I'm going to add the value of the 6. It's in the ones place, so it has a value of 6. So 6 times 12. So I've set up the distributive property. I've broken apart 16. I've got 10 plus the 6 gives me 16, and I kept the 12 factor. Whenever we're multiplying by multiples of 10, we know that anything times 0 is going to be 0, so I'm going to have a 0 in my ones place. Then I'm going to multiply 110 times 12. 110 times 12 is 12 tens. So 10 times 12 is 120, which 12 tens equals 120. So now I have to solve for 6 times 12. All right, and so we've been practicing our facts, but some of the students are still kind of struggling with 6 times 12. So they may say, ooh, I know 6 times 10 is 60, and then I need 2 more groups of 6, so 6 times 12 is 72. All right, so now we have 16 times 12 equals 120 plus 72. So the last thing I need to do to solve 16 times 12 is add up where I broke it apart, and I have 120 plus 72. So I would get, and we were talking about eggs, dozens of eggs, so that would be 192 eggs. I hope this visual helps you. It's a great strategy. It makes the problems friendly for the kids, and it makes them, as you can see, this is a 2-digit by 2-digit, but it makes it friendly. And they're not afraid to do that because they know their place value, they know how to manipulate the numbers, and they know how to make it work for them. They could break apart 16 any way they wanted to, as long as what they broke it apart was 10 plus 6, that equals 16. So they could have broken that apart and said 8 and 8, because 8 plus 8 is 16. So there's no certain way to break apart the factor that you're breaking apart, as long as it equals the factor you're breaking apart. I hope this helps. I'm going to check real quick and make sure there were no questions. Anyway, I hope this helps. I'll be uploading it to YouTube in just a second and sending you the link. I hope you guys have a great evening. Thank you.